All right, so as we continue through our Unit 2 on functions, today we're going to look at representing functions with tables, graphs, and equations. So today's goal is to represent a function using a table, graph, or equation. So let's go ahead and get started with tables, okay? So for a table, that just means that we have an x and a y, or an x and an f of x. Remember, f of x is just y. All this is a y. We just use this new notation because it's a function. Alrighty, so given the function f of x equals 2x plus 3, complete the table. So I'm given a bunch of x's to start with, 0, 1, 2, and 3. Alrighty, so I'm going to use my evaluating functions unit from last week and go ahead and plug in those values. So f of x, or f of 0, is going to equal negative 2 times 0 plus 3, and then I'm just going to keep simplifying. Negative 2 times 0 is 0, plus 3 is 3. So in here, I put a 3, because when I plugged in 0, I get 3. And then we keep going. So now we're going to do f of 1. Every time I see an x, so negative 2x, I'm going to put a 1 plus 3. And then we do the math. Negative 2 times 1 is negative 2, plus 3 is positive 1. So I'm going to put a 1 in the table. And continue. F of 2 is equal to negative 2 times 2, plus 3. Negative 2 times 2 is negative 4, plus 3 is equal to negative 1. So now I have a negative 1 in my table. And last one, f of 3 is equal to negative 2 times 3 plus 3. Negative 2 times 3 is negative 6 plus 3 equals negative 3. So I'm going to put a negative 3 in my table. Alrighty, so this is just evaluating functions. All of this was the x. This was negative 2x plus 3. But instead of x, we put all of these numbers, 0, 1, 2, and 3, and solved to get our f of x. Okay. Remember, we also talked about how x is called the input or the domain. So this is also input. So when I input x into the equation, my output is that y or f of x value. Alrighty, so that's our table. Let's take a look now at our completed table, and now we're going to turn it into a graph. So what if I wanted to represent a function as a graph? I can turn it into a table first. So I have my table of values. This is the same one we just did. Alrighty. And now I can use these values, remember this is just y, as x, y points. Alright, so this one is 0, 3. This one is 1, 1, 2, negative 1. And 3, negative 3. So I'm just going to plot those as points and then connect whatever pattern I have. So 0, 3 is up here on the y-axis at 3. Over 1, up 1 is here. To the right, 2 and down, negative 1. And then to the right, 3 and down, negative 1, 2, and 3. So we're plotting all of those points. And when I connect those, I get a nice line. Oh, that is horrible. Let's try that again. All right, so we can connect those into a straight line, and hopefully your line looks a lot better than mine does. All right, put arrows on either side because this function can go on forever, okay? This table is just to get us enough points to graph something. It does not mean that these are the only numbers that go into this function. This function works forever. So this line could keep going all the way past our screen if we needed to. So we're always going to draw arrows on the end to show that this could go on forever. This pattern follows. All right, let's take a look at equations, okay? So in the function that we already had, we had f of x equals negative 2x plus 3. Where the heck did this negative 2 and this 3 come from? How do we even know that that is the equation? Well, we can pull that from the table and the graph, okay? So this is our table that we've already done. This is our graph that we just completed. These were the points that we had. We had 3, 1, 1, 2, negative 1, and 3, negative 3. All right, those are all of our points that we just had. A linear function, which is what we have and what we're going to be dealing with for the time being, takes the form f of x equals mx plus b. Alrighty, so that means that there's a number in front of x and then there's just a regular old number by itself. This m is called the slope, okay? Or it's also called the rate of change. And it always goes with x in the equation. B is my y-intercept, which is when x is 0. So whatever the y value is when x equals 0, okay? So let's take a look at our equation here, and we're going to see how we found that -2 and that 3, all right? First of all, let's take a look at the 3. The 3 is the b. It's the number that's all by itself. It's the constant. So that happens when x equals 0. So I can look in my table, when x equals 0, my function is 3. So that's where I get the 3 from. It's when x equals 0, okay? On the graph, I also see it happening right here on my y-axis. So wherever it is touching the y-axis, this up and down line, my y-axis, that's telling me what the b value is, what the number by itself is, okay? If I'm looking for that -2, I want to figure out how that happened. For the table, I'm going to look at the pattern of my function. So how does a 3 turn into a 1? We have to do -2. And a 1 to -1 is -2. And a -1 to -3 is -2. Okay? And all of these numbers are increasing by 1, so I don't need to worry about my x values. So from the table, I just look at how does my function go as long as my x values are increasing by 1. In the graph, I just go from one point to the other. I have to go down 2 and over 1 to get to the next point. So I'm going from this point to this point, to the next one that I can see. So I have to go down 2 and over 1 to get there. So that means that I'm going -2 over 1, -2 over 1, which is just -2. So I look at how did my y's change divided by how did my x change. All right? Most of the time, it's going to be a whole number for us. Let's take a look at an example. Write the equation of the functions below. So let's take a look at the one with the table first. So I'm going to figure out how did each of these numbers change. All right? So I'm going to first look down here at 5 and 8. I know that from 5 to 8, I had to do +3. And 2 plus 5 is +3, which means -1 plus 3 is 2, and -4 plus 3 is -1. I'm just figuring out how did each of these numbers change, okay? And if they're a function, they all changed by the same. So if the negatives are hard, just look at the positives. How do we go from 5 to 8? We have to do +3, all right? So that means that I have a slope. My m is +3. Now I need my b. Remember, b is the number when x equals 0. So here's 0. My b is -4. So my function is f of x equals 3x minus 4, because that 4 is negative. That's it. So the change goes with x, and when x is 0 goes all by itself. All right, let's take a look at the graph. My b is always where it touches the y-axis, and my slope, or my rate of change, I have to count. So right here on the y-axis, which is my up and down line in the middle, the purple line, this graph goes through it at 1. So that means b is 1, okay? And now I'm going to use this to figure out how far it's going to go, what my rate of change is. So I'm going to start here, and I'm going to look for a point that is perfectly on like one of these corners. We always want it to be on the corner of a graph because that's going to be a perfect point. And I see one right here. So I'm going to go from here to here. All right. So if I do that, I have to go 1, 2, and then over 1. So I have to go up 2 and over 1 to get there, which is just a +2. So my function is f of x equals 2x plus 1. Remember, the slope goes with x, and the number that touches the y-axis goes all by itself. Alrighty, I'm going to give you a minute to try this one on your own, okay? So remember, you're looking for b is the number on the axis, and b is the number on the axis, and your slope, you have to count from one point to the other. You have to go up and over or down and over if your line is negative looking. Okay, so go ahead and try the next one and press pause so you can work on it, and then press play when you're ready to see it worked out. All right, let's start with our b because that's the easiest thing to see right here, touching the y-axis. So my b is 5. My m, I need to go from one point to the other. Luckily for us on this graph, they have the points labeled. So we're going to go from this point to this point. Okay, so we're going to count 1, 2, and I went down, so I had to go -2, and then I have to go 1, 2, 3 over. So it's -2 over 3 because I had to go over 3. So then my function, remember m goes with the x, so -2/3 x plus 5. And there's my final function. All right. Let's go ahead and try matching these. So you have some graphs and some tables. We're going to match them to the appropriate equation. All right. So let's take a look at the table first to make it a little bit faster. My x, when x is 0, my number is -1. So this one automatically goes here because I have that -1 in the b spot. Okay. If I look at my pattern also, 2 plus 3 is 5, 5 plus 3 is 8, -1 plus 3 is 2. So I have to add 3 every time, which is this number right here. All right. When x is 0, y is 2. So that means this one goes to this one. My intercept is 2. All right. And for this one, I have to do -1, -1, and -1 to get to that number. So that's why we have this negative. Remember, there's an invisible 1 in front of that x, so we just call it -x. All right. Now let's go ahead and take a look at the graphs. So again, fast thing is to look at this number. I want the y-intercept to be at -1. So when my graph touches -1 on the y-axis, that's going to be my graph that goes for that one. And then I want this one to touch it too, and this one does touch it too. So then this is my graph for this one. All right. Again, we check our slope. So I would go from here to here. So I go down 1 over 1. So that's -1. And for this one, I'm going to look at this point right here because this one is not on the corner. Notice they gave us a point, but it's not on the corner. Remember, we want to talk about all of the corners of those boxes. That's what we're always looking for. So I would go up 1, 2, and 3, and over 1. 3 over 1, which is 3, which is why it goes here. All right. So we can turn our functions into tables, and then we can turn our tables into graphs, and we can turn all of them back into equations. The main thing to remember is that b is the number when x equals 0, and the one that touches the y-axis when it's on a graph. M is the change. How is each number changing? Okay, and it can be positive or negative. Alrighty, that's us being halfway through with functions. So I will see you back here next week when we're talking about transforming the functions. Have a wonderful rest of your day.